Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to lecture number 12 for the course of routing and switching. My name is Engineer Jaffar and I am instructor for this course. So you know that this is our lecture number 12 and this is the first part of that lecture. And the topic of today's lecture is going to be point-to-point protocol. In the last class we have discussed about two topics. One was the LAN, local area network, and the second one was VLAN, virtual local area network. I have described you how you can basically implement or configure these two networks in your systems or your domain. So the next topic is going to be point-to-point protocol, and in this lecture, this is the lecture brief, and in this lecture we are going towards to see the starting introduction of this point-to-point protocol (PPP) and this design requirements of this protocol, and what should be the data frame format for this protocol. And later on we will discuss about something very unique phenomena known as bit stuffing. This is a very cool phenomena. I'm going to tell you about this as well. And later on we will discuss about the control protocol, and in the last we will having some question answer session in the class. So let's revise an OSI model. You know that this is your OSI model, and this is your host layers and this is your media layers, and this first three layers on the you know that this is on the host layer side. So you can see that their data unit is basically a data, and the transport layer, this data becomes segment, and later on it becomes data, a gram or a packet, and then it frame, and finally to bits. And these are the function of different layers of this OSI model. So no need to revise that, because you know that this was the initial of this course. This was the starting of this course of routing and switching. So let's dig deep into our topic, that what is basically point-to-point protocol. So this is also known as PPP, but you should not confuse this PPP to P2P. The other P is P2P is basically peer-to-peer network, and there is a small difference between this point-to-point and peer-to-peer. So the point-to-point protocol is for communication between two computers using a serial interface. You can call it a phone or a single communication link. You can call it a link as well. But what is peer-to-peer? Peer-to-peer is a basically communication model in which each party has the same capabilities, and either party can initiate a communication session. For example, say BitTorrent. So BitTorrent is a perfect example of a peer-to-peer in which you know about the seeds and the peers that you want to download. So this is basically two-way communication. But what is point-to-point? It is basically a single interface. You can say call it phone as well. So it is a single serial interface communication. So what is point-to-point protocol? The point-to-point protocol (PPP) provides a standard method for transporting a multi-protocol datagram. You see that this is basically able to provide you a multi-protocol datagrams transmission over a point-to-point links. So you can basically use this protocol to transmit multiple protocols datagram. This is not limited to only one protocol datagrams. It is basically capable to maintain and transmit multiple protocols datagrams. So this PPP is comprised of three main components. So we will discussing this as well in the next part of this lecture too. But for now, it is a brief over here. Method. The first main component is basically the encapsulation. So a method for encapsulating multi-gram protocol, it is used for that purpose. The main component of this is as well a link control protocol or LCP for establishing, configuring or testing a data link connection that you can basically establish using this LCP. You can basically establish, configure, or as well as you can also test or verify or check the status of a already established data link connection. So this is also used for that LCP. And in the last there is basically NCP, that is network control protocol. So that this P2P also provides you the capability to check the status or configure or establish that different network layer protocols using this P2P. So let's talk about some of the design requirements that you should be verify, or you should satisfy these requirements before actually starting working on this PPP point to point network. So this first one is basically packet framing. You know that the data that comes from the, you can see that this is data, a datagram or packet. So this is coming from this network layer. So from network layer you get this packet, and you have to make this packet into the frame. And I skip that. This basically, this protocol is on the data link layer. So this protocol lies on the data link layer, and so the first requirement for this is basically data packet framing. So packets are basically transferred as, or you can say shifted into frames. At the start and end of each frame you should be placing some flags, or to basically identify the start and the end of the flag. The second one is basically transparency. The network layer packet should be capable to handle this kind of transparency. This basically includes the format representation, different kinds of headers and data as well. The next one is multiple network layer protocols. This means to be able to support multiple network layers protocols. For example, you have learned quite a lot. I've already discussed with you IP, RIP, ICMP, IGMP, OSPF, BGP. We have discussed lots of routing protocols. So multiple network protocols should be supported by this, running over the same physical link at the same time. So it doesn't mean that you have established a point-to-point connection or point-to-point link or point-to-point connection actually, and it only supports to one protocol, routing protocol. So it doesn't support that. So you have to be very careful, because if you are establishing a point-to-point network or P2 or PPP, so it should be something like that connection which basically supports all of these routing protocol. Similarly, there are multiple links involved in this kind of communication. You can say variety of links: serial, parallel, synchronous, asynchronous, low speed, high speed, electrical, optical. So this link should be able to basically satisfy all of the customer needs or all of the requirements for the user. Similarly, there is basically configuration of error detection. This should be able, your configuration should be able to detect bit errors in the receive frame. The next one is basically connection liveness. So your connection should be able to detect a failure at the link level. For example, if you have transferring some data, and after in between some after some time, or in between the transmission, there occurs some link failure. So this PPP connection should be able to basically observe that and detect that connectionlessness, and you should be able to inform you so that you can recover that packet, or you can change the link as well. Similarly, it is mentioned over here that it should be able to detect a failure at the link level. For example, the inability of data transfer from sending side of the link to the receiving side of the link, and signal this error condition to the network layer. So you see, it has to be basically not only observe or detect that, but it has also to report this kind of failure to the network layer as well. The next one is data network layer address negotiation. So it is basically the mechanism for communicating network layers, for example IP, to learn and configure each other network's layer address. So this is a very cool format as well. This is a very cool phenomenon actually. And the last one is simplicity. This means that the first and the foremost among all the requirements, this is the very much your protocol and your design should be in such a way that it should be as much simple as possible, so that in the future or for someone else to understand, it would not be that much of difficulty. This is basically RFC 1457 states that the watchword for a point protocol should be simplicity. So this is nothing but a request for comments, and it was basically mentioned over here that the protocol should be as much simple as possible, so that the coming or the future generation can understand it very easily. So what not to consider when you are designing? So the first one is error correction, required to detect bits, but this is not required to be correct. So this error correction is not required most of the time, because it basically mostly in the correction techniques are first of all they are costly, and second thing that achieving a good policy for the error correction is not that much of efficiency, or not that much efficient. So it is better to retransmit that packet either to correct it or rather than to correct it. Flow control only receives only at a full rate of the underlying physical layer. No need to control the upper layer. So you have to get the flow control of the lower layers instead of controlling the upper layers. So this is also a cool. You know that this flow control is also there in the transport layer. So you do not have to take care of that as well. You only have to verify or check the status of the physical layer, and you have to make sure that the physical layer is basically maintaining its flow at a specific rate. The next one is sequencing, not required to deliver frames in the same order. So it is also not required that the packets should be or the frame should be received in the same order that it was delivered. So it is not basically no condition for the transmission or the reception as well. This is mentioned of delivery, but it is not delivery means from the transmitter towards the receiver. So there is the condition is set in such a way that it is not conditional, or it is not required to the packet to get received on the receiver inside in the sequence. So it is not required at this point. And the last one is multi-point links. Only a single sender and a single receiver should be there, because you know that point to point includes only a single sender and a single receiver. So there should not be more than a single sender and a single receiver. You know that point to point means from a point to another point, and this involves only one sender and one receiver. So this is a kind and the data frame format for this PPP. The first, there are basically, you can see that this consists of flags, and this flag is basically a delimiter, or you can say framing. This provides, I've told you that you have to put a flag instead of start of or end of any frame, or you can also put a flag on if you want to identify something. So this flag is basically a delimiter, or used for framing as well. It is mentioned over here that you should be using flags for the framing. Address can be used, but it is not used in this PPP, as no support addressing used in HDLC broadcast address. So you can see that there is no there is basically mentioned the space of this address, but mostly it is not used in this PPP, because for this address to be used you have to basically put another supporting packages as well, but that is not included in this, so that is why it is not used. The next one is control. You can see that 1 byte of control is given to you, and this is always something like this, 6 zeros and 11, and this is basically transmission not sequence, connectionless link. So this indicates that this is not the sequenced. It is not sequenced. I have discussed you that there should be no sequencing required. You can see that no sequencing required to deliver the frame. So that is also mentioned here, the transmission not sequence, and it is connectionless link. The next one is protocol, the upper layer protocol to which the frame delivered. For example, you are using this at data link layer, you know that, and the upper layer is basically IP layer. So you should be highlighting the upper layer format as well, that what type of upper layer protocol is that is used. There can be IP, there can be IPX, or there can be Apple Talk, or there can be any network. Or there are mentioned several networks or several protocols that can be used in the network layer, but it should be highlighted in the data frame of this as well. You can see that it is mentioned that you have to identify the protocol of the upper layer as well. And info means upper layer data being carried, that what is the length of the data, what is the code of that data, what is the message of that data. You can see that this is the ID of the data, the code of the data. So this is basically the info about the information that is basically on the upper layer. The next one is padding. You know about the padding. Padding is basically you have to add some dummy bytes to make a complete package. For example, if you have let's say you want to transmit a packet but you only have six, let's say six bits, and to make a complete packet you have to let's say these are six packets, these are six packets, 6 bits, sorry. And in order to make a frame, let's say you want to add two additional bits, so for that you need to have, you can add two dummy bits over here, let's say 0 0. These two are dummy bits, but this will make a complete packet, and for that, and after that you will be able to transmit this packet. So this phenomenon is known as padding. So in some cases additional dummy bits may be added to pad out the size of this PPP frame. You can also add can also add it is totally up to you if you want to add or not, but mostly it is added. And the last one is basically you can you can see that this is a check, and for this is only used for the error detection only, detection purposes. You can see that cyclic CRC or error detection for any you can use any type of parity checks over here as well, but mostly CRC is used over here. And in the start and the end of this data format, this data frame, you can see that there are basically flags which will show the starting and the end of this data frame. So this is a format for a data frame for which this PPP is supportable. Now the next very cool phenomenon is known as stuffing. Now what is stuffing? For example, if you receive, this is the question, I will tell you that what is stuffing and you will get a clear idea. If you receive let's say 0, 6 ones and 0, it is a data or a flag. So you can basically you can by judging a simple byte of data, you can actually address that it is a packet or it is a data. So sender add stuff or bits, you can say extra bits after each byte, after byte, so that you can be you can basically understand that this is not basically flag, this is not data, this is actually a flag. So let's say transmitter is sending 10 packets and they are mixed together, but it will want the receiver to know that these are basically 10 different packets. So after every packet he will stuff some same data, let's say this is the same data, and after each packet he will adjust this data, then another data will be sent for the system, this will be another data, and after that data another this stuffing byte will be stuffed into the channel, so that if the receiver knows, it will only receive this and then it will discard this, then it will receive and store this and it will again discard this. So this stuffed byte will be the data that is discarded at the receiver, and after that the other data is basically received and stored in the form of its own. So you can see that this is basically your stuffed data, 0 6 ones and again 0 6 ones, and this was before and this was BB. So you can see that there is a stuffed, these are stuffed bytes, there are two stuffed bytes in between them. Now let's talk about the control protocol. This image is not showing over here, I'll see what is the problem. It starts from here. You have to establish a link phase. You can see that this is a phase that is basically initializing the link. Now if the link is basically successfully established, you can go further, but if it is not, you can repeat this phase again and again, unless, and this is the closed loop. You can see that this loop will be running again and again, unless and until the link is established. If the link is established, let's say this link is established, it will go into the next phase, that is the authentication phase, and I will tell you how this is authenticated as well in the coming slides. So if first of all, the network and the protocol will see that if the authentication is required by the users or not. If it is required, it will go into the authentication phase. If it is not, it is totally up to the users and the managers of the, or you can say the administrator of the protocols or the network. So it is totally up to them. If they want to basically make this authenticated network, they can go at this route, and if they do not want any authentication, they can go directly to the network layer protocol phase. If this authentication is required by the administrator, so this will go into the authentication phase, and in the authentication phase they will basically see and check if the user has the authority to enter to the network or not. So if it is correct, it will go into the successful phase. If the authentication is successful, it will go into the network layer phase, and if the authentication is not successful and it gets failed, so this will lead only to the termination of that link, and this link will be terminated and it will go again into the re-establishment of dead link, and it will go again to the establishment of new link. So this will be keep going again and again. And if the network is basically doesn't require any authenticity, or it is the network has authentified this new user, so or this link, so this will enter into the network layer phase, and it will do the protocol over there, and after that the link will be terminated. So at the end of each this loop, all the links is basically generated and terminated again and again. So this is a very cool phenomenon of this control protocol. This is how these links are basically established, maintained, authenticated, and terminated at the last. So these are 3-4 steps process. So the authentication involves three phenomena. The first one is protocol. That what is the value of this protocol? Protocol are basically, there are two protocols. The first one is PPP and the second one is CHAP, and the value of this protocol in Hexa is basically C23 and C223. So these are two protocols actually. So first one is password authentication protocol and challenge handshake authentication protocol. We will be discussing that protocols in the coming slides as well, but for now, for this you can only have an idea that in the PAP, that is password authentication protocol, user has to start authentication request. User will initiate authentication request, and it will send its own username and password to the server, and the server will respond back either with the acknowledgement or not acknowledgement. You can see that this will be initiated, this PAP protocol will be initiated by the user or the client, and it will be responded by the server actually. And these are the packet formats. You can see we will discuss that in class inshallah in detail, but this is mostly the same thing: the length, the username, the length of the password, and the password. And this is the authentication request. You can see that the request basically is a long thing, and it basically identifies the user or the client's credentials, and the acknowledgement will be the message and the length of the message. It will be yes or no, or connection established or connection failed, etc. And not acknowledgement will be the same thing. And this is all stored in the information phase. This is over here. And in the start, you can see that start and end will be flags, and there will be address, there will be control, there will be protocol of the upper layer, and this will be all stored in this phase, this information phase. So this is basically a PAP, and it is let's revise it. So it is basically initiated or originated by this client, and it is responded by the server. The next one is challenge handshake authentication protocol, CHAP, or you can say CHAP. So this CHAP is basically nothing but it is if a user wants to connect to a point-to-point network, so the server will by default originate or you can say start a challenge, it will start challenging the users that give me your credentials, give me your response, and the user will respond back with the username and the password, etc. And after that, that server will decide that if this user is authenticated or not. If it is not, it will send its failure, and if the server see that this is my own user, it will send him a success message. So this is the same code. You can see that this codes basically identify what type of message it is. So the first one is the challenge message, the code 2 represents response message, code 3 represents success message, and this code 4 represents this failure message. So depending upon the code, you can also judge this, and this will be the value: challenge value, response value, username, and message value. What will is the message? Is it a status or connection established or connection failed? It can be determined over here, and this all information will be stored in this information space. And this is same. You can see that flags are over here, starting and the end of the data frame, and address and control and protocol. You can see that this is all the same. So this is basically a three-way communication, or you know that handshake is a three-way process, but it is originated or initiated by the server. Server will come and challenge the user that please provide me your credentials, and the user or the client will respond back it will provide its credentials to the server, and the server will decide if it is going to be connected to a part of this network or not. So this is a Wireshark demo. This is a frame format. Let me tell you how this is done. You can see that this is the same thing, starting and the ending of the frame, and the address and control protocol, and this is information, and at the end this is basically a CRC, or you can say error detection mechanism, FCS. And this is the information this is the information, the code, the ID, the length, and the message. Let's see how does it works in the Wireshark. Wireshark is basically a tool that is there to basically configure the point-to-point network or point-to-point protocol. This is same to something like packet tracer in the Cisco. We talked about the packet tracer in the class, and this is also this one of its kind. And this PPP, basically you can see that it is basically initiated with the routing protocol of RIP. You can see in the caption that this PPP is basically combined with this RIP protocol, and you can see these are the messages with the timestamp and the source and the destination and the protocol that is resolving and the information about that. So you can see that all these are basically configuration requests. All these want to be configured, and this is basically the acknowledgement, and again the connection request, the configuration request. So this is your point-to-point protocol. You have to provide address, you have to provide control, you have to provide link control protocol, LCP, and then you have to identify the configuration request. This is the basically request packet. So this is basically code is basically configuration request. This is configuration request, and this is basically the length and identifier. There are several things that you can find out using this. You can see that this is now PPP with IC PC. So these are several other messages. You can see discard request, configure request, and a protocol reject, and configuration not acknowledged, configuration acknowledged. So there are several tools. This is out. You can see that you can say that this is the tool for this working on this PPP protocol. So these are the some references that I have gathered for you. You can also read this RFC 1661, and I have also mentioned RFC another one. Let me tell you, RFC 1457. So these are two RFCs that I have taken from as a reference. So you can also consult that as well. So this was all about the first part. I hope that you have learned quite a lot. In the second part, we are going to learn this more of these PPP. There are a few topics that are remain, and they are not that much exposed or digged So we will be digging that topics in too much detail in the coming slides of the lecture 13 part B. I hope to see you there. Thank you very much. If you have any questions, please write it down and ask me in the class. I'll see you in the class. Thank you very much. Allah Hafiz.